example 4-18 over here, we are going to measure different voltages, not voltage drop across the resistor, but voltage points with reference to the ground. So as we mentioned in the lecture section of chapter 4, if we have a single subscript, if we have BA, it would be this point with reference to the ground. If we have two subscripts like BAB, that would mean the voltage difference. It would be a differential voltage between point A and point B. So this is exactly what they are asking here. They're asking to find the voltage difference between these points. And they are going to give A, B, C, and we have to keep solving what is the difference between those 2 points. So let's start. Voltage number 8, excuse me, says find the voltage VAB. VAB. So the voltage VAB is equivalent to say voltage A minus voltage B. So what is voltage A? It's the voltage between this point and ground. So I can go from here, through that resistor, and through that resistor to the ground, or I can go from here to this source to the ground. So it's easier to go this way. So B1, if I go here positive and then ground, so B1, BA is the same as B source, which is equivalent to 25 volts. For BV, we use KVL. So for me to start using KVL, I can calculate the voltage total so that I can do voltage divider as we learned it in the previous video. So just in case I need it, I'm going to calculate it here to be 12.5 kilo ohms. BV, it's going to be, I'm going to this point. This is BV. So I can go voltage drop across this resistor, voltage drop across that resistor, and that takes me to ground. Or I can go voltage drop across this resistor, voltage drop across this source. So there is 2 different ways to do it, but I know that if I go through here, I might need it later, so I'm going to go this route. So BV is the voltage drop across B2 or R2 plus the voltage drop across R3 or V3. Okay, so voltage drop across R2 using voltage divider, I'm going to say V2 is R2 divided by total times the source. So I get 16.4 volts. Then I do the voltage drop across V3 or R3, the same thing, voltage divider, R3 divided R total times V source is equivalent to 6.6 volts. So VV, I'm just going to add 16.4 plus 6.6 is equivalent to 23 volts. But I'm not finished. Now I have the voltage V and the voltage VV. So now I have to subtract them. I have to say, okay, VAV, it's VA minus VV, which is 25 minus 23. I get 2 volts. But if I look closely to this circuit right here, VA is just actually the voltage across this resistor, which is V1. So I can check my answer and I can say V1 is just R1 over R total times the source, which is 2 volts. So it is the same. So they check out. Okay. And then I can go the other route. I can say, okay, I can go BV plus B1 plus the source to see if I get that. So if I do that, I'm going to say B1 plus B source. B1 is negative because I'm going this direction. So I'm entering the resistor from the negative. So that's why it's negative, and then this one is positive. So they subtract instead of adding. So it's 23. So now part number 3 says BAC. So it will be the BA, I have it to be 25 volts. VC, we don't know. Let's see what VC is. So point C is right here to here. So point C is just V3. So V3 I have calculated here to be 6.6 volts. So right here I recalculated again. So V3 is just, VC is just V3 to be 6.6. BAC is 25 minus 6.6, so it's 18.4 volts. And then number C, it says B voltage VC, so V minus C. So V voltage V, I have calculated right here to be 23 volts. So if I go here, VB is 23, VC I have calculated to be 6.6, so it's 16.4 volts, and then point D. Point D right here, it is just ground, because I'm connected to ground. So VCD is going to be voltage C, which is voltage 3. Voltage VD is just 0, so my VCD is going to be 6.6 volts. A potentiometer is an adjustable voltage divider. So a potentiometer is going to be when we have 3 terminals. So we have one terminal, we have the other fixed terminal, and then we have the third terminal, which is the voltage out. So here is where we are going to be monitoring or regulating how do we want to split our potentiometer. Our potentiometer is going to give us a one value, and that one value means you're going to have 0 resistance all the way to this value. In this case, it's going to be 10 kilo ohms. So if I put it right in the middle, it's like if I had 2 resistors, 5K and 5K, and I'm getting my V out from the middle, which if this is connected to a source, it will be just half of the source. Power in series. Power in series is the power dissipated by each resistor in a series circuit, contributes to the total power in the circuit. So P total is P1, P2, P3, all the way to Pn. And P total can be calculated by voltage times the current squared times the resistor, voltage squared divided by the R total. So in this example right here, it says what is the P total? So I have my different resistor, I have my source, I find my R total, I multiply it to find 100 ohms to be my R total, and from here I can find my P total, right? V voltage squared divided by R total gives me 2.25 watts. This formula is interesting because I never had to find the current. Just by the information given, I just calculate for the voltage current, and then I was able to find the voltage, the watt consumed, which is the same as the watts of the power produced. So whatever is produced by the source, it has to be consumed by each individual resistor, to the point that when I get back to here, I should have 0 power. Now it says calculate the individual powers and show that they add up. So I have my voltage source to be 15, my R total to be 100. So I calculate my I total or I source to be 150 milliamps. Now I'm just going to carry that across, change the value of the resistor according to each value of the resistor given to me. I'm going to square this, and then I'm going to find all my different voltages. So if I add them, they add up to 2.25 watts. So it is the same as my power source or my power total. Right here, this is an important concept that we have to talk about. Open circuit. Open circuit, we have, it's one of the major failures in series circuits. So what is it? When we have an open circuit, there is no current flow. We have broken the path. We don't have a closed path. So we have the source, we have the loads, but as far as closed path, it is a open. There is no connection, and current cannot jump from here to here. So that's why it is an open. There is no current. The current is equals to 0. So it prevents the flow of current. This is a major problem in electrical circuits, in series circuits. So right here, we know that, how do we know that there is no current? Because B1 is going to be 0. Why is B1 equals to 0? Because the current is 0. B2 is equals to 0 because I is equals to 0. So what we see at the end right here, this is the V source, and what we see here on this other end is 0 volts. A short circuit. Short circuit also becomes a big issue for series circuit because the whole chunk of the circuit can be removed from the circuit. So let's see here. We have a resistor R1, R2, R3, and R4, and accidentally these two terminals are connected by a simple jumper wire. When current flows, current is going to get to this point and it's going to decide, do I go here, which I have 0 resistance, or do I go through here, which I have R3 and R4 as resisting me. So obviously 100% of the current is going to come through here, avoiding all these resistance. So this circuit will actually be coming to just R1 and R2. So this is going to change the whole genetics of the circuit, because R3 and R4, voltage is going to be 0, current is going to be 0. They are like they don't exist here. So the whole circuit is going to be changed. The current is going to be modified. The voltage across each resistor is going to be modified. So we have to be careful with that. So short circuit means resistors are removed. Open circuit means resistors are removed, but there is no current. While in short circuit, there's still a current. It's just not what we are expecting.